Consider this scenario of calculating the compound interest. We are supposed to calculate the interest on a sum of $4,000 for 2 years at 10% per year. Okay. So our parameters are principal is P, which is 4,000, the time period, total duration of the loan is 2 years, and the rate of interest is 10% per year. Okay. And we have to do it in two ways, compounded annually and compounded biannually, means interest is calculated every 6 months. Okay. Now we know that the formula for calculating the total amount due for compound interest is A, the total amount is equal to the principal times 1 plus R over 100 to the power n. Okay, where R is the rate of interest per period and n is the number of periods in question, correct? So in this case, for the case 1, when we want to compound annually, the R is 10% per year, correct? And the number of periods, in this case, n will be equal to 2 because we want to calculate interest every year, right? And there are only 2 years in the question here, right? So n will be equal to 2. Now we already know the value of P, so let's calculate the A. The amount paid back at the end of 2 years will be 4,000, which is the principal times 1 plus 10 over 100 to the power 2. Correct? And as we solve it with a simple math, this becomes 4,000 times 1.1 to the power 2, and this will be $4,840. Okay, and this is the total amount paid back after 2 years. However, we are supposed to calculate what is that compound interest. So the interest will be simply a difference of the amount paid back minus the principal sum that was borrowed, which will be 4,840 minus $4,840. So this is the compound interest after a period of 2 years when we compound annually. Okay. In the second scenario, when we are compounding every 6 months, we have to align our parameters a little bit. So if you consider this timeline, that there is a time period of 1 year, right? In that 1 year time frame, I'm computing interest every 6 months. Okay, so the 1 year is divided into 2 parts, correct? And each period becomes a compounding interval, right? And then comes my next year right here after this. And this year will also be divided into 2 parts, and then I will have 2 more compounding periods, right? So in total, I will have 1, 2, 3, 4 compounding periods, right? But at the same time, now this gives me the value of n, but at the same time, my rate of interest, that is 10%, that 10% is for 1 full year, correct? It is not for half year. So if that is 1 full year, then every 6 months, what should be my rate of interest? We simply divide that into 2 parts because 1 year has 2 compounding periods, okay? So we want to have a rate of interest for each compounding period, right? That is our objective, right? So in that case, I'll divide my rate of interest into 2 parts because 1 year has 2 compounding periods. So that becomes 5% every 6 months. That becomes my new rate of interest, okay? So in that case, I'm going to use these two values, the 5%, which becomes the rate of interest for each compounding period, and the number of periods into my formula of calculating the total amount due, right? So let's substitute all these values in that equation, and we say that A, the total amount due at the end of 2 years will become 4,000, the principal sum, times 1 plus R, which is 5% in this case, right from here, to the power 4, which is this value of n. Okay, now that comes out to be equal to, when you do the simple math here, $4,862. Okay, and I'm just truncating all the decimal digits, so we will ignore that for this calculation purpose. But this is the total amount paid back at the end of 2 years. So my compound interest in this second scenario will be the total amount paid back minus the original amount borrowed, which becomes $862, right? So you notice that the interest paid in second scenario is higher than the interest rate in the first scenario, right? And this is because we have increased the frequency of compounding. Even with the same parameters, the frequency of compounding does impact the total interest that is paid back at the end of the total loan duration. And that is why compounding interest is so much liked by banks.